Now, before we get into properties and naming alkanes, let's just talk briefly about how to represent organic molecules, because we're going to draw a lot of organic molecules from now on. Before we get into alkanes thoroughly, let's talk about how to write structures. There are three ways of representing organic molecules. The first one is structural formula. Structural formula. How do we write that? For example, if we had, say, C4H10, the molecule that we talked about in last video, right? C4, right? H10, right? So, four carbons and 10 hydrogens, and we're showing how they're all connected. This can be written in a condensed form as CH3, CH2, CH3, right? CH2, 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 CH3, right? So what does this tell us? This tells us that these carbons are all connected and each of them have these number of hydrogens connected to them, right? So we write it as CH2, 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 CH3. This is the condensed formula. Now, another way of representing organic molecules, that's known as the line structures. Line structures, right? What are the features of line structures? A carbon-carbon bond is represented as a line. Okay. Anywhere the line begins or ends, as well as any vertex where two lines meet, that represents a carbon atom. So if you see something like this, right? This is where two lines are meeting. So this is a carbon atom, right? Any atom other than carbon or hydrogen must be shown. Only carbons and hydrogens are represented as lines and vertices. Every other atom like nitrogen and oxygen, all these things must be shown specifically as the symbols. Now, since carbon forms 4 bonds, if specifically a bond is not shown, then it is understood that it is a CH bond. So how do we put this into perspective? Say you see a structure like this, right? Oh gosh, what is this, right? So remember, every vertex, every point is a carbon. So this is a carbon, this is a carbon, 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 and carbon. So let's write it like this: carbon, 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 right? And of course, this carbon, right? Now remember, anything other than carbon and hydrogen need to be represented. So if you saw a line structure that looks like this, right? There's nothing else and there's no hydrogen, no oxygen, nothing. So all the 4 bonds of carbon need to be filled out by another carbon or hydrogen. So this carbon, 1 bond is for this carbon. So 3 other bonds to hydrogen. 3 other bonds to hydrogen. 2 other bonds hydrogen and 3 other bonds to hydrogen. So this molecule is CH3, C, CH3. Notice that I'm putting this in parentheses, meaning this CH3 is a connection to this carbon exclusively, and then a CH2, CH3. Okay, we will practice more of this in the class.